Hello. As you know, resource limitations can sometimes be a major issue when simulating complex real-time models. In some cases, this may require model optimization, which may result in a less detailed model. Today, let's look at a new feature that may help you avoid these issues altogether, by improving your CPU memory utilization and increasing your available CPU power by up to 50%. Typhoon Hill simulators are based on a heterogeneous multiprocessor architecture. Every Hill device has these three elements: Typhoon FPGA solver, system CPU, and user CPU. The Typhoon FPGA solver is optimized for simulating the electrical domain part of the model in real time. The system CPU is typically used to either simulate low dynamics phenomena of certain electrical domain components, or to handle communication protocol stacks. A few examples of components that utilize system CPUs are voltage RMS and single-phase constant power load. In the vast majority of cases, there is no need to change any of the default parameters of the system CPU. In contrast, the user CPU is under direct user control. It executes submodels composed of signal processing components, such as gain, alpha beta to DQ transformations, sums, and many others. In a nutshell, until now the signal processing part of the circuit was executed on the user CPU, while the system CPU so far was exclusively used for RMS measurement and constant power load components. From the 2021.4 software release, this functionality is improved. Signal processing components can also be mapped to system CPUs. This lets you distribute the signal processing workload among CPUs more evenly. Let's now see how to use this feature. You are probably familiar with CPU marker components, which you may have used to map the signal processing model to a specified CPU core. Now, as part of the CPU core label, there is an additional system CPU option after the core number. In order to allow this functionality, it is necessary to choose the option System CPU, and then click OK. This instructs the compiler to execute mark part of the circuit on the system CPU. This also applies for RMS voltage measurements. By double-clicking on that component, and then on Signal Processing tab, you can see the Pin to System CPU checkbox. This is enabled by default, meaning the RMS voltage measurements will be mapped to the system CPU, just as in previous versions. By unchecking this box, it means that the signal processing inside the component will be mapped by the standard algorithm that is applied to signal processing partitioning and run on the user CPU. The main advantage of this feature is that it brings more CPU power for our models. This is especially important for the fourth-generation devices, Hill 404 and Hill 606, where the system CPU is the same type as the user CPUs. Typically, the system CPU is underutilized since constant power load is used less frequently than signal processing components. This means that using this feature in fourth-generation devices, we can expect up to 50% increase in the available CPU power. Let us know your impressions about this feature. Thank you for watching.